We're going to be looking then on your test, which isn't that far away. I'm hoping to get to it in about a week and a half, at two types of graphs. Position time graphs, the slope was the velocity, and today, velocity time graphs. I bet you we're going to try and talk about what the slope means. So the motion of an object with uniform motion. Allison, that was the fancy way of saying no acceleration, a equals 0. Boring! But we did that. Is best represented by a position versus time graph. D or P on the y-axis, T on the x-axis. The motion of an object with acceleration, or for those of you that like the notation, a changing velocity, is best represented by a velocity time graph. What that means, Jessica, is on the test and in your homework from now on, when you see a graph, look at what's on the y-axis. And I'll tell you, it's either going to be position or velocity, but it means totally different. Make sure you read carefully, Sage. Turns out, the slope of a velocity time graph is the acceleration. The slope of a position time graph is the velocity. The slope of a velocity time graph is the acceleration. Oh, remember, acceleration, I'll put a vector so you know that's acceleration and not the letter A, is measured in, what are the units for acceleration? Meters per second squared. So, here is a, what kind of a graph? Velocity versus time. So if we analyze this, you'll notice after 1 second, how fast is this person going, roughly? Around 12 or 13. In fact, if I had to put money, I'd say 12 and a half. After 2 seconds, how fast is this person going exactly? 25 meters per second. After 3 seconds, 37 and a half. But you know what? After 4 seconds, exactly 50, their speed is increasing. Their speed is increasing. If we want to analyze this, now in your homework, Allison, you do not need to show me this much work, but I'm going to fill out all the steps so when you're studying, you know what the heck we did in our notes. Slope is what over what? Rise. We'll write that in our notes. Over run, just to reinforce that. And I even drew a little slope triangle, the little dotted line. The rise is that distance right there. How high? Rylan, how high right here? How high right here? 25. Okay, 50, 25. What's the rise? If I end up at 50 and I start at 25, what's the rise? In other words, how long is this line here? Yes, don't overcomplicate it, okay? 50 minus 25, it's 25 again because I picked nice numbers. Oh, the answer is always 25. No, it's just highest number minus lowest number. It's what you in math called y2 minus y1. What's the rise? 25. Rylan, I'm coming back to you. So this is the rise. The run is this. Don't count the squares. Look at the numbers. Where are we right here? Right here. 4 seconds. Where are we right here? The total time elapsed is? Yeah, every year I have some kid who tells me that the run is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it is 8 squares, but please look at the scale. Don't just count the squares. Look at the numbers. Don't just count the squares. Look at the numbers. So Rylan, if I hear you correctly, it's that? Or as a decimal, in your head, what is 25 divided by 2? 12.5. 12.5 what? Well, it's actually 12.5 meters per second because the rise is from the y-axis, and you'll notice the units on the y-axis are meters per second, over 2.5 seconds, because on the x-axis, 2.5, Mr. Dueck, 2, sorry, let's try that again, Mr. Dueck. It's 12.5 meters per second per second. The rise is meters per second. The run is seconds. What is meters per second per second? The slope of a velocity time graph, Courtney, is acceleration. And you can memorize that, but I've tried to show you a way that you can kind of figure it out from the units, because it's the y units divided by the x units, because it's rise divided by run. It's meters per second divided by second. It's meters per second per second. It's meters per second squared. I use that in physics 12. There's like 60 graphs, and I teach my kids to figure it out by looking at the units. You don't memorize all the graphs. Waste of time. Key idea. The slope of a velocity versus time graph is what's the punchline? If it's a key idea, it probably means it's important. So now we have 2 ways to calculate acceleration. Kyle, we can defic. I can give you the numbers and the data, and you can use your formula sheet, or I can give you a picture. There are 3 different types of motion graphs that we're going to be looking at. Position time graphs, velocity time graphs, and acceleration time graphs. We're hardly going to look at that third one. Mr. Dueck? Yeah, Max. What's the slope of an acceleration time graph? A jerk. Really? Yeah. Mr. Dueck? Yes, Max. What's the slope of a jerk versus time graph? A snap. Mr. Dueck? Yes, Max. What's the slope of a snap versus time graph? A crackle. Mr. Dueck? Yes. What's the slope of a crackle versus time graph altogether? A pop. I kid you not, in physics we have a good sense of humor and we know how to name things. Not like these biologists that name everything with Latin. God. It's true. But you'd have to have an incredibly complicated initial position versus your position time graph would have to be very, very complicated for you to be able to get that many slopes that far down. In fact, I can't think of an example off the top of my head where that would work. But what I've told you is considered accurate. What's the slope of this graph here? I can tell you, 2.5. How did I figure it out that fast, Sage? I didn't go rise over run. This is what kind of a graph, Sage? What versus what? Versus, hey, what is the slope of a velocity versus time? And so all I did was I looked and saw how high the acceleration line was. Oh, 2.5 meters per second squared. If you're accelerating, can you see your speed is increasing? Now, how does that affect a position versus time graph? Instead of having a graph with a straight line, what do you have? A curve. If you're accelerating, position time graphs will be curvy. How do you find the slope of a curve? That's why Isaac Newton invented calculus. We won't be getting into that. But take calculus and you'll find out. It's really quite cool. So, we can use each type of graph to analyze the motion of an object, or we can compare the motion of two objects. An object with a constant, you know what, I don't want to write the word acceleration out. A constant acceleration has a, what does v dash t stand for when I put a vector sign above the v? Can I write that instead of writing out the word velocity versus time? Okay. Here is an object that has a constant acceleration because the acceleration is horizontal. What can you tell me about the velocity versus time graph? It has an acceleration, velocity versus time graph that is a blank line. Straight, but not flat. I'm going to repeat myself. The slope of a VT graph is? It's the key idea. Means if you know the acceleration, you also know how steep the slope, the velocity time graph is. Turns out, the area underneath a VT graph represents, actually not position, displacement. I'll be fussy. Alex, what color did I write this in? That was purely nerd trivia. But for what it's worth, if you give me a velocity time graph, the slope tells me the acceleration, and if I were to calculate, for example, that area, I would know its displacement over that time period. There's a lot of information there. A negative slope on a VT graph indicates negative acceleration. If you were traveling forwards, but the slope is negative, it means you're slowing down. I can't always say a negative acceleration means you're slowing down, because in free fall, a negative acceleration can also cause you to speed up. That's all about direction. So I'm not going to give you a general rule. I'm going to say you got to think about each question. Oh, your general rule is imagine you're sitting there. Which direction is the acceleration compared to what your body feels? Always backwards. Okay? That's the general rule. That'll work every time. So, we're going to, on your test, give you some graphs to sketch. On the provincial, Allison, what they'll do is they'll give you multiple choice graphs to pick from. It says, sketch, Allison, what kind of a graph? Velocity versus time to go with position versus time. Okay. So what kind of a graph did they give me, Allison, my joy? Versus, where does velocity appear on a position versus time? Slope. Slope. So you ready? It looks like things change after 4 seconds and after 8 seconds. So I'm going to go like this. 4 seconds, 8 seconds. My graph's going to have 3 chunks. You okay with that, Matt? Okay. And you know what I'm going to do first? I'm going to find the slope of this right here. Slope is what over what? Okay. What's the rise? Let's see. Oh, since we start at 0, the rise is 6. What's the run? So I'm going to say, do you guys have a letter that you use for slope? Because I'm sick of writing the word S-L-O-P-E. Don't you have a letter used in math? Okay, so I'm going to say m equals 6 over 4, which is what? More specific. Sorry? 1.5 or 3 over 2. What that means is that section there would be a line 1.5 high on a velocity time graph, because the slope of a position time graph turns into velocity. That horizontal line is the same as that slanty line on a position time graph. Try and make it a little neater than mine. You see I drew it, Sage, exactly halfway between 1 and 2? 1.5. I'll change colors. Sage, what's the slope of this section right here? Oh, so what's your velocity? What's the slope of that line right there? What's your velocity? Ready? Yes, with authority. What's the? I'm asking you the same question. I'm phrasing it 2 different ways, but it's going to be the same answer. What's the slope of this line right here?
0.
And what's your velocity for this section right here?
0.
So that's going to be a horizontal line 0 high, like that. Is that okay? Sorry? Question, Court? Okay. I'll do the next one in green. This slope here, negative or positive? This velocity here, negative or positive? Negative. Okay. What's the slope here? Negative. Six over, I think the rise is 6 and the run is 3, or negative 2. So now I got to eyeball it. I have to go chunk, chunk. I think this would be like that. So there's two ways to look at this. I can, Julie, look at this graph. Here's what this graph says. From where I started, I went forwards, I stopped for a while, and I came back to where I started from. Or, I started going forwards, I stopped for a while, I went backwards, which I'd have to do to come back to where I started from. You get the same information from each graph. Let's do an ooh. Let's do another one. Looks like we have a change 2 seconds in, so I'm going to go Looks like the next big one is 4 seconds in. Right there. And then nothing happens, 7 seconds in. And 10 seconds in. Okay. So put the dotted lines in. And once you've done that, put your pencils down. What's the slope of a position time graph? Velocity. What's our key idea today? What's the slope of a velocity time graph? What's the slope of that line right there? As a number, what's the slope of that line right there? 0, you weren't accelerating. For this section, you're going at a constant speed. For this section at rest, you're going at a constant speed. For this section here, you're going at a constant speed. There was some wonkiness going right in between and right in between, but I don't have enough information to figure out how I got from one to the other. Pick your pencils up. What's the slope of that line there? Positive or negative? What's the rise portion? You're starting at 2, high. You're ending up at 6, over. What's the run? How far sideways are you going? You know what? This has a slope of, this has a velocity of, same question, same answer, same question phrased differently. You know what? I got to eyeball this. There's -1, there's -2. The first section of this would be like that. What's the slope of that section there? You're at rest. 0. Psst. Little focus. I know, this is tough stuff. Ooh! What's the slope of this section here? Well, positive or negative? Positive. What's the rise? Well, there's a few ways you can do this. You could go from here to here and say the rise is 12 and the run is 2. Or you could go from here to here. We end up at 12. We start at -6. You could say the rise is 18 and the run is from 4 to 7, 3. You'll notice 12 over 2, 18 over 3. It really doesn't matter, Ty, where you pick. I usually pick what's easiest. I probably would have gone from here because it lets me use a 0. And I'm good at math with zeros. But what is the slope? Right? What's the slope? Positive or negative? And by the way, I hope this is also helping because I noticed in the last chapter, which I didn't give you guys the test on, a lot of you were confused about the graphs. And that's when I said sometimes it's easier to look at all 3 graphs kind of at the same time. That helps them, you figure out what's what and what's what and what's what. Courtney, this slope here, negative or positive? Yep. What's the rise? I start how high? I end how high? What's the rise? Yeah, negative, but we already put the negative in. What's the run? Yep. In your head, without a calculator, what's -12 over 3? Okay, you know what? I'm going to have to go, because there's -2, there's -4, and I'm going to have to somehow draw this in like that, I think. Sorry. Cam, what's the slope of this last section? This section right here. How fast am I traveling right there? Ooh, you know what? I was going to get you to say 0, and then my next question was going to be, what's another word for that? You jumped the gun. Very nice. Physics word. Yeah, at rest, which means, that would be, I would argue, Ty, it's easier for me to figure out the data from this graph than from this jumping around thing, but they're both valid. Turn the page. Nearly done. Okay. Matt, my friend, anytime you have a new graph, read the y-axis. What was on the y-axis of this graph, Matt, my friend? Read to me. Velocity. Is this a position time graph? Everybody say no. No. This is a velocity time graph. What does the slope of this graph tell me? Acceleration. Okay, I got to shift my thinking. All right. During which time interval was the acceleration 0? Right there. Right? Between, oh, you know what? I'll go t equals 8 to 10. During which interval is the acceleration positive? Sorry? From 0 to 8? So, if positive is forwards, I don't know. Oh, east. Speeding up. Constant speed, not at rest, constant speed. Slowing down. Which section is the acceleration negative? T equals 8 to 14, is that right? During which section is the object increasing its velocity towards the east? Same as the positive. When is it decreasing its velocity to the east? From 8. Oh, sorry, not from, you know what? This should be from 10 to 14. Someone should have been yelling at me. 10 to 14, not 8 to 14. And 10 to 14, Mr. Dueck, not 8 to 14. That was silly. Acceleration isn't negative right there. Acceleration isn't negative right there. Hey, when is the object moving at a constant velocity? Lots of information. A couple more, we're done. During which time intervals? I formatted it wrong?
Over the graph.
Yours went over the graph?
Yeah.
Mine didn't.
You can only see like one column.
Okay, look up. Let's do this one together. I don't know why that happened, because... Can I see what yours looks like? Weird. This is the same copy when I hit print, and this is what it looked like on... Okay. No, it's probably an obscure photocopy driver issue, to be perfectly honest. Anyways, I'll muck around with it another time. Hey, can you tell me, instead of time intervals, let's do it this way. Look up. Let's call this section A, B, C, D, E, F. I've divided this line into chunks. Hey, what letters is the acceleration 0 for? Oh, did you look? What kind of a graph is this? Because they might have snuck in a position time graph. So velocity versus time graph. Where is the acceleration 0? B? Where else? F. Where is the acceleration negative? A and D, right? Where is the object increasing its velocity north? C and D. Now, this is kind of strange because here it's still going backwards or south, but it's slowing down. So this is like you're driving in reverse, but you're braking, you're getting ready to go forwards. Where is it decreasing its velocity? Oh, here's another typo. I just noticed that. Should say the word north. So I'll fix both of those. Section E, section A. By the way, yours says north? Yeah. Where is the biggest acceleration on this graph? If I asked you that, what am I really asking you to find? Biggest slope. Go rise over run for each one of those. You could, we're not gonna. Where is the object moving at a constant velocity? B and F. In fact, I can tell you the velocity. It's moving at 6 meters per second south, or you could say negative 6 meters per second. And here, not only is it moving at a constant velocity in section F, what is its velocity in section F? 0. Cam, what's another fancy word for a velocity of 0? It's stopped. But the stopwatch kept running. Ah! No? Oh, I got sage. I was aiming for Matt, and I was a little to the right. So, you ready? I want you to see if you can try doing these 1, 2, 3, 4 sketches as part of your homework. I'm giving you a position time graph. See if you can sketch what shape you think the velocity time graph is. And then I have some more homework for you to practice as well. So, you can work by yourself or with a partner. In fact, it may be good for you to try and the whole attack, defend, convince thing that we did before class. Your homework, Courtney, try these 4 graphs, and then the handout that I gave you is sketching velocity versus time graphs. See, I did not include answers this time. See if you can sketch what you think are the correct graphs. I'll go over these Friday. Got 10 minutes. You can probably get it all done. Actually, you got 20 minutes. No, 10 minutes. You can get it all done if you hustle.